Hey everyone, NerdTeach here, and welcome. Get ready because we are about to embark on an epic quest into the enchanted forest of algorithms. Together, we're going to decode two of the most powerful forms of magic in all of computer science.
I mean, you know that feeling, right? You're staring at a problem, and there are just 1,000 different paths you could take. You have no idea which one leads to the treasure and which one's just a dead end. It can be totally overwhelming.
Well, what if I told you we could take that maze and turn it into a grand adventure? Today, we're going to equip you with the spells and the strategies you need to navigate any computational quest you can imagine. Our journey starts right now.
Okay, so every great adventurer needs two things, right? They need powerful tools and they need a really clever plan. In our world, those are recursion and backtracking, and it is absolutely crucial to understand that they are not the same thing.
Here's the best way to think about it. Recursion is your tool. It's like a magical spell that lets you create copies of yourself to explore a bunch of different paths all at once. Backtracking, on the other hand, that's your technique. It's the strategy a wise knight uses to explore a dark forest, knowing exactly when to push forward and, just as importantly, when to turn back. So put simply, recursion is the how, and backtracking is the what. So what is this magical cloning spell really? Well, recursion is just a programming pattern where a function calls itself. It's all about breaking a giant, scary problem down into smaller, identical, and much more manageable pieces. It's kind of like telling a clone, hey, you go handle that little part of the maze over there, and I'll just wait here for your report.
But wait, you might be wondering, how does the system not get totally confused with all these clones running around? Well, every single time the spell is cast, that is, every time a function calls itself, it creates what I like to call a memory scroll. The technical term is a stack frame, and this scroll, it remembers everything, all its local variables, the parameters it was given, and, most importantly, the return address, which is just the directions on where to report back to when its little quest is finished.
Now, a spell that creates infinite clones would be, well, a complete disaster. It would use up all our magic, or in this case, all our computer's memory, and that's exactly why every single recursive spell needs what's called a base case. Think of it as an anchor to reality. It's a simple condition that tells the spell, okay, stop cloning now and start sending back the treasure you found. Without it, you don't have an adventure, you just have chaos.
All right, we've got our cloning spell. We understand how it works. Now, let's learn the strategy for actually using it. It's time to venture into what I call the decision forest, a place where every single path is a potential solution to our problem.
And this, my friends, is where our wise knight, our backtracking strategy, really gets to shine. It explores this decision forest by navigating something called a state space tree, which is really just a fancy map of every possible choice you could make. Our knight takes one step, checks the surroundings, and if the path ahead looks, well, cursed, it immediately retreats, no questions asked. This brings us to the real magic of backtracking. It's a concept called pruning. You see, instead of acting like a brute force troll and trying every single path all the way to the very end, our knight is smart. The moment a path violates the rules of the quest, they just chop off that entire branch of the decision tree. This saves an unbelievable amount of time. So, if you remember one thing from today, let it be this mantra: choose, explore, unchoose. It's the heartbeat of backtracking. First, you choose a path to go down. Then you explore it, and this is often where you cast your recursive cloning spell to send a scout ahead. And finally, if that path leads to a dead end, you unchoose. You step back, and thanks to that memory scroll we talked about, the world goes back to exactly how it was before you made that choice. It's like it never happened.
Okay, theory is great, but let's make this real. Imagine a classic quest, the N Queens problem. The goal is to place N magical queens on a chessboard so that no two of them can attack each other. Using our mantra, it's simple. We place a queen, that's our choose. We then recursively try to place the next one, that's explore. And if we get stuck and can't place a queen, we just remove the last one we placed and try a different square, that's unchoose. It is the perfect trial for our wise knight.
So, our knight is pretty wise, for sure. But even the wisest hero can use some magical artifacts to help them on their quest. In the world of backtracking, these are called heuristics, and they can make our search, well, incredibly more efficient.
First up, we've got the lens of focus, or what's technically called minimum remaining values. This artifact is all about a simple idea: tackle the most difficult part of the puzzle first. By choosing the variable that has the fewest possible options, you're way more likely to find a conflict early. It's what we call a fail-first strategy, and it helps us prune huge parts of that decision forest right from the get-go.
Next, we have the key of flexibility, or the least constraining value. Now, once you've used the lens to pick the hardest problem, this key helps you pick the easiest answer. It tells you to choose the value that keeps your future options as wide open as possible. This is a fail-last approach, and it makes it way more likely that the path you're currently on is the one that's going to lead all the way to a solution. And for our last artifact, we have the guardian at the gate, also known as forward checking. Think of this one as giving you the ability to peek one step into the future. After you make a choice, the guardian immediately checks on all the neighboring problems to see how your choice affected them. If it sees that any neighbor now has 0 possible moves left, the guardian screams "Stop!" and forces you to backtrack right then and there. It saves you from wasting time on a path that was already doomed.
But every adventurer has to be careful. The forest isn't without its dangers. You see, powerful magic always comes with powerful risks, and it's time we talked about the curses you might run into on your journey. We need to be on the lookout for 3 great curses. First, the abyss of memory, which you probably know as a stack overflow. Second, the curse of endless branches, or exponential time complexity. And third, a really nasty trap that affects servers, known as a regular expression denial of service attack, or RDoS for short.
So remember those memory scrolls we talked about? The abyss of memory, or stack overflow, is what happens when our recursive cloning spell goes way, way too deep. The stack of those memory scrolls just grows and grows and grows until it literally consumes all the available memory, and your whole program just crashes right into the abyss. This is exactly why that base case, our anchor to reality, is so vital.
Now, for that hacker's dark spell. This is a very real-world danger that shows up in something called regular expressions, which are these super powerful patterns for searching through text. But some of them use a backtracking algorithm that, if written poorly, can perform catastrophically. Now get this. The source material warns that for some of these patterns, a tiny string of just 30 characters is enough to make a powerful server hang for minutes or even hours.
This vulnerability is called RDoS. And what happens is a hacker can send a specially crafted piece of text that forces the server's backtracking algorithm into an insane, exponential number of steps. It basically traps the server in a cursed loop, eating up all of its resources until the entire application crashes. It is a huge security risk that can take a whole website offline, and it's a pretty sobering reminder that our night strategy has to be wielded with care.
So, we've been through a lot, haven't we? We've faced the maze, we've learned the spell, we've mastered the strategy, and we've been warned about the curses. And with all this new knowledge, you've been transformed.
You're not just a coder anymore. You are now an algorithm adventurer. You get the deep connection between the tool and the technique, between the spell and the strategy. And now you're ready to go out there and tackle your own complex quests, to prune your own decision forests, and to find those elegant solutions in a world that is full of complexity.
Thank you so much for joining me on this quest today. If you're ready for the next adventure, make sure you join the guild by hitting that subscribe button. And hey, if there's a dark corner of computer science you want me to shed some light on, suggest your next quest for us in the comments below. Thank you for joining me, and until next time, keep exploring.